Here are the solutions. This is really not a quiz, but a review of what we've done so far with polynomials. So can you factor and tell me the zeros? So we'll do it together. Hopefully you've tried it first. So we're going to factor out an x, and then it's a simple trinomial. Two numbers that multiply to 14 add to -9. It's -2 and -7, and then the solutions over here. So those are the zeros. We factor it, and then remember what x value makes it 0. So they're opposite numbers. Number 2, we need to go 25 times 4 and then -29. The two numbers are -4 and -25. They multiply to 100, add to -29. Then I come back here. I do a substitution. I take out -29 and put in -4 and -25. Order doesn't matter. Make sure it's x squared because that's what 29 was. And then we group them together. So we factor out x squared. That's 25x squared minus 4. Factor out a -1. That's 25x squared minus 4. Make it equal to 0. So we have x squared subtract 1. We have 25x squared subtract 4. Both of them are a difference of squares. X plus 1, x minus 1, 5x minus 2, 5x plus 2. So a difference of squares by square rooting and square rooting. One's adding, one's subtracting. So we have plus and minus 1, and then plus and minus 2/5. Those are the zeros. Number 3, we're going to look at the first two terms and factor it. So that's x squared. We're going to look at the last two terms. That's -25. Oh, that's a 2. So we have x squared minus 25 and x plus 2. X squared subtract 25 is a difference of squares. See if I can write it. So now that it's fully factored, then the answers can go here. So the zeros are plus and minus 25 and -2. All right. Take out a common factor. That's going to be -3x squared. That leaves me with 9x squared minus 4 by dividing. That's a difference of squares. That's 3x plus 2 and 3x minus 2. And then this is 0. This is plus and minus 2/3. And you have your answer. So you add or subtract 2, divide by 3. Number 5, good news, it's already factored. Well, at least one of them is. So this is -5/2. The exponent, it's 5, which means it's odd, which means it crosses the x-axis. The next one is -4. It has an even, so it touches in terms of the exponent. And the last one's +1. You don't see it, but the multiplicity is 1, which means it crosses. Here we need to do some factoring. So I'm going to factor out a 3x squared cubed. 3x cubed. That gives me x squared plus 4x plus 4. Two numbers that multiply to 4 and add to 4 are 2 and 2. So instead of going 2, 2, I write it squared. And then we have a 0. That's odd. So it crosses. And then -2, that has an even multiplicity, or you can write down 2, and that means it touches. Nothing for the last row. All right, next one, we're going to do some division. Can I use the shortcut here? I sure can. +1, 1, -6, 0, -1, and 3. Be careful about the missing power. See if I can add and multiply okay. And then you have your answer. Oh, and it's going to be 1x cubed. So it's 1 degree less. And then -5x squared, -5x, -6, and then the remainder. All right, turn the page. This one I have to do long division. It's not a simple linear, the divisor. So we're going to do make sure we don't have any missing powers. and then start dividing. So power term divided by power, so 15 divided by 5, and then subtract the exponents. Now multiply. So that's 12x cubed. And then the remainder, so it's 2 take away 12, that's negative 10. Bring down the next term. Again, divide. That gives me negative 2x squared. Multiply. That gives me a remainder of 0. Bring down the next term and the next term. So now it's just negative 30 divided by 5, which is negative 6. So there's no x term there. That's negative 30x minus 24. When you subtract a negative, you're adding. So it's really negative 22 plus 24. So that's 2. And then your answer. So that's 3x cubed minus 2x squared, subtract 6. And then a fraction. So it's 2 over 5x plus 4. All right, number 9, again, I got to use long division. Make sure there's no missing powers. All right, power term divided by power term, that's 2x. Subtract. Make sure you multiply each one and then put the answer down. So when you subtract the negative, you're adding, so it's end up with negative 1x squared. Subtract a negative, that's adding. That's negative 5 plus 10. Bring down the last term. And then again, divide the power terms. And you get negative, you get positive, and positive. All right. So I get left with a remainder of negative 1. So how do I write this answer? So it's 2x minus 1, and then the remainder is a fraction. So 2x minus 1. And then a fraction, which would be 1 over x squared minus 5x minus 5. Awesome. All right. The remainder theorem, can you evaluate the remainder theorem? So at this number, we use it. Don't change the sign. That's 1, negative 9, 15, and 25. Did I miss a power? No. All right. So now multiply. Make sure I do this correctly. And so this is what it means. That means f at 4 is equal to 5. So if you do the work correctly, the remainder is gives you the answer for the evaluation. Okay, same thing here. Don't change the sign. Make sure there's no missing. There's a missing power. And then I get negative 5. So that means f at negative 1 is equal to negative 5. All right, last page. Use the factor theorem. So this one we are going to change because we're given a factor. So it's positive 9. And then 1, negative 10, negative 3, and 108. I know the remainder here is going to be 0 if I do it correctly. Oops, 12. And then I have x squared minus x minus 12. So that's x minus 4, x plus 3. So fully factored, we have x minus 4, x plus 3, plus the factor x minus 9. Here, that's really this right here. Yes, it's a factor because the remainder is 0. And then the zeros are 4, negative 3, and 9. All right, number 13, negative 1. That's 2, 14, 16, negative 32. I get the remainder, negative 6, so is it? No, and then I don't need to do anything else. So it's not a factor, so I can't keep going. That was nice, right? 2 more left here. Let's see, is it a factor? It is a factor, so yes. because the remainder is 0, we have 3x squared minus 8x plus 5. So 3 times 5 is 15 and negative 8. So the two numbers are negative 5 and negative 3. And if I factor out the first two, that's x, and that's negative 1. So in factored form, I get 3x minus 5, x minus 1, and x plus 2. And that gives me positive 5 over 3, positive 1, and negative 2. Okay, one left. Hopefully you tried it first. So again, I'm going to divide here. 2, negative 7, negative 23, 28, 60. So there's a remainder of 0. I have 2x cubed minus 3x squared minus 8x minus 12. So it is a factor. I'm going to factor out an x squared, 2x minus 3. I'm going to factor out a negative 4. That's 2x minus 3. That gives me x minus 4, 2x minus 3. I know this is a difference of squares, so I'm going to write it in factored form. So that's x plus 2, x minus 2. That's the difference of squares, 2x minus 3. And then the first factor that I started with in the question, x minus 5. And now it's fully factored. And each factor has a 0 here. So we have positive and negative 2, positive 3 over 2, and positive 5. Right? Did I do that one? I think so. Oh, you know what I did wrong? This should say positive 3. So this is a positive 3. That's right. I thought I did something wrong. All right, so that makes it negative 3 over 2. Now it's right. Mr. G Math, over and out. I'm proud of you for getting your work done.